Alright, continuing with Chapter 2, we're on Section 2.5, Part 2. Solve each formula for the specified variable. So for number 2, we have A equals P plus PRT for T. Alright, so you look for T, and there's actually only one term where there's a T, so we want to isolate that term. So step 1 would be to subtract the P, just as if this was something like 3 equals 2 plus 4t, you would start by subtracting 2. So if you don't know where to get started, change all your variables to numbers and then see how you would do that problem. So the first thing we're going to do is subtract p from both sides. Now there isn't a like term on both sides, right? So you'll just have to write that as a minus p equals PRT. Alright, so we're trying to solve for t, so we have to think of this PR as the coefficient. So you need to divide by that, PR. So you divide both sides by the same thing, PR. And so now, on the right-hand side, the PRs would cancel, and I've solved for t. It's a minus p over PR. So you have a minus p over PR equals t. So the answer is t equals a minus p over PR. Now you might do this problem differently. This isn't the only way to solve it. This is the most natural way for me to do it. Alright, we solved this for t. What if instead we wanted to solve it for p? Let's say we wanted to solve it for p. How would you do this? It's a little bit more complicated. We have a equals p plus PRT because there's a p in two different places. So if you have something like this, it's a little bit tricky. You have to think of combining like terms. So you have to think of this as a 1 is the coefficient of this p, and the coefficient of over on this side is RTP. So you see there are the two coefficients, 1p plus RTP. So the first thing I'd have to do on the right-hand side is combine by adding the coefficients. Well, they're unlike terms, so you'd have to write it as 1 plus RT. That is the coefficient of p. Now, if the coefficient was 3, you divide by 3, but in this case, the coefficient is that big mess, 1 plus RT, so you would have to divide both sides by 1 plus RT. So p, if you solve for p, it'd be a over 1 plus RT. So that's a little bonus problem. It's difficult. If you could do that, then you've really got the idea. Number 3, V equals 1/3 AH. We're going to solve for H. So I have to isolate H. I have a 1/3 A times H, so the coefficient of H is 1/3 A. Now, if you want, you might want to write 1/3 A as A over 3 times H. Sometimes it's easier to see it like that. And that way you could just multiply both sides by the reciprocal, 3 over A. So we can multiply both sides by 3 over A. So that H is now the only thing left on the right-hand side of the equation, and I have 3V over A on the left-hand side. So that's a one approach to the problem, which means that H is the same thing as 3V over A. Now, another way to start this problem is to multiply both sides by the least common denominator because you have a fraction. So I could do that by multiplying both sides of the equation by 3, each term. So I would have 3 times V equals 3 times 1/3 AH, and that way you don't have any fractions. You have 3V equals AH, and then you could divide by A. So that would take 2 steps instead of 1 step to get the same answer of 3V over A equaling H. All right, so those are a couple different ways to solve for H. Number 4, y equals mx plus b. We're solving for x. This is the formula that we use in graphing. Those of you who have had algebra before, you may have seen it. I won't go over what this stands for right now, but this is a formula when you're graphing lines. So we're going to solve for x. So there's only one place there's x, right? Here, this term, the mx, so I want to subtract b from both sides. Just like if it was a plus 3, we would subtract 3 from both sides. So these are unlike terms, so I have to just write y minus b equals mx. And now the coefficient of x is m. If it was a 5, you divide by 5, but it's an m, so we divide by m. So we've got y minus b over m equals x. So the answer would be written as x equals y minus b over m. Part 3, solve. The formula used for converting Celsius to Fahrenheit is F equals 9/5 C plus 32. Convert 30 degrees Celsius to Fahrenheit. So what we're going to do is plug 30 degrees in for C, and then we'll be able to tell what it is in Fahrenheit. All right, so we've got to solve F. We're trying to find F, so we have 9/5, and instead of C, we're going to plug in 30 times 30, and I'm going to write 30 over 1. I'm not going to put in the degrees right now. We'll do that when we write the final answer. So there we go. I'm plugging in 30 for C, and now we just simply solve for F by simplifying the right-hand side using the order of operations. So 5 goes into 36 times, so that's going to be 54. 9 times 6 is 54 plus 32, which is 86. So the answer is 86 degrees Fahrenheit. So 30 degrees Celsius is actually pretty warm. 86 degrees Fahrenheit. I think in terms of Fahrenheit, so when somebody says 30 degrees Celsius, I really don't have much of a feel for what that is usually, but that's how you can do it if you're in another country, if you want to know how hot that is Fahrenheit. We use the same method for converting negative 15 degrees Celsius to Fahrenheit. You take the formula again, and this time we're going to plug in negative 15 for C. So we know this is going to be negative something, right? Because a positive times a negative, and I cancel. The 5 and the 15 goes 3. So 9 times 3 is 27 plus 32, and that's 5. So that would give us 5 degrees Fahrenheit, so that negative 15 degrees Celsius is 5 degrees Fahrenheit. By the way, 0 degrees Celsius is freezing point, and that's the same as 32 degrees Fahrenheit. So that's why you're below freezing Celsius is going to be negative, and below 32 degrees Fahrenheit will also be freezing.